Hey everyone, and welcome to a new video on this channel. This one is about using a vector database called Pinecone together with OpenAI to ask natural language queries about blog posts on a blog. We'll use my blog, blogbaka.info, as an example. Let's get started. The application we are going to build can query my blog, blog.baka.info, with natural language. For example, suppose I want to know how to create a chatbot with OpenAI, then I can type in the question here and select the OpenAI model. The default one is this one here, the turbo model. If you have access with your API key to GPT-4, you can use that model as well. Let's stick to this one and click submit. Now, when you click submit, several things happen. First of all, the query here is vectorized, and we use the OpenAI embeddings API to do so. When we have that vector, we can see how close it is to the vectors of my stored blog posts. And that algorithm is coming up with this blog post, which looks quite close to me. This is the correct one that it picked out. Now, of course, that query, that vector comparison, has nothing to do with OpenAI. We do that with a vector database called Pinecone. Now, what we do after we found the URL, we're just going to download the entire text of the post from that URL. And we're then going to submit the same question here, the natural language here, the same question, how to create a chatbot with OpenAI. We're going to submit that to the GPT-3.5 Turbo model, but we provide the contents of this URL, we provide this contents as context, right? Then OpenAI has all the information it needs to say, yes, indeed, the article you've given me, that's the content of this URL here, it's relevant to the question, and here are the steps that you have to follow. Now, of course, if you're asking questions that come up with a result that is not relevant, what will we get in that case? For example, if I ask how to center a div, which I have not written about on my blog, just to be sure, well, if I click submit here, what's going to happen is our vectorized search will come up with an answer, but the answer is not really correct. It's actually an article about Docker without Docker, a look at Podman. For whatever reason it came up with it, that's not relevant at all. But the prompt that we use in the OpenAI question is actually going to instruct to say, well, when the article is not relevant, say so, and then answer beyond the context that I've provided to you. So here, the model is saying, well, actually, I can't find how to center a div in the context you've given me, so that's not relevant. But hey, to center a div, you can do the following thing. Whether that's right or wrong, I don't really care, but that's how it answers here. Now let's take a look at the architecture that's behind all this. We'll first need to create vectors from our blog post and store them in some database. Now, we could have stored these vectors in a local text file and so on, but there's this vector database called Pinecone, which is software as a service, and it allows you to easily store vectors, a lot of them, in a vector database. And Pinecone also allows you to do the vectorized search, so finding out your query and then your posts, what are the closest posts to the query that you entered in the UI. So we first have to grab all our posts here from my RSS feed. We'll use feed parser in Python to do that. And then when we have each article, we will create a vector from that article with the text embedding ADA002 model from OpenAI. That's kind of a cheap one to use, so that's not really something you have to worry about from a cost perspective, especially if you only have, let's say, 50 or 100 or a few hundred posts. That's not really an issue. When we have the vectors generated, we're going to just store them in that vector database. Now, the UI that you've seen before is generated by another application, which is just a Flask web application. It will ask a question to the user, you have seen that, a query, and that query in the fourth step here is then again vectorized with the OpenAI embedding APIs. When we have this embedding, which again results in just a vector, we're going to use an API offered by Pinecone to do a similarity search. So we're going to compare the vector of our query with the vectors in the database, and we're going to find the best matching article to our query. When we have found that best matching article, we're going to go out and go to the OpenAI ChatCompletion API, where we ask the same question again, but as context, we provide the entire article to the ChatCompletion API. Especially if you use GPT-4, you have quite some room to provide context because the max tokens for that model is higher, at least double from or when compared to the GPT-3.5 Turbo model. So that's the, let's say, general architecture. Let's take a look at the code. You can find all the code on GitHub. Just go to github.com/gbake and then /GPT vectors, and you should see all the code over here. In the console folder, you'll find the Python applications to upload the vectors to Pinecone, and also a small utility to search the vectors from a console app over here. But the actual web application that you've seen, you can find this in the web app folder. In the web app folder, you'll find an app.py, and that implements the Flask web app that allows you to answer a query and then get a result back. Before we look at the code, ensure you have an account at pinecone.io. You can just use your Google or your GitHub credentials to create the account and log in. Now, the first thing you need to do is go to the API key section over here and just copy the API key value with this button, and also record the environment that you're in. It might be the same as this, but also could be different. We'll need the environment and the API key in our Python program later. Now, we will create our index and actually recreate our index every time that we are uploading our blog articles, but you could also create a blog index or any index here in this indexes list. You can see the blog index already created. If you want to create your own index, you just create an index over here, enter a name, the dimensions, and then the metric to calculate or to get to your similar documents. Now, it's important, of course, you get the dimensions right. And in our case, because we use the specific ADA002 model from OpenAI to create the embeddings, the vectors that result from that API call those vectors have 1536 dimensions. So if you're using that embeddings model, the same one I'm using in the code, make sure you type in this number of dimensions here. There are different metrics to choose from, but it must be said that cosine similarity is the one that OpenAI recommends when you use the embeddings model that we are going to use to create vectors. Now, again, you don't really have to do this because we will create the indexes from the code that I'm going to show you next. Let's first check what the script does. So it's the upload vectors.py script that we're talking about here. Just going to minimize this here and then run that script. So Python 3 in my case, and then upload vectors.py. Now, when I run this, what you'll see is it'll check if the index already exists. If the index exists, it will delete the index. It will then create the index from scratch and go through all my posts, vectorize my blog posts, and store the vectors in Pinecone. Now, I will speed this up a bit so you don't have to wait too long for this to finish. And here's the code of the script that we just ran. So ensure, of course, you import all the necessary libraries over here. And the first thing that we'll do is we'll set the OpenAI API key from an environment variable. We also set that we needed the Pinecone API key and the Pinecone environment string. You could grab that from the Pinecone portal. Now, once we have set this, we can initialize Pinecone with the init method. We just specify the API key and the environment that we just loaded. Now, as I've discussed, we are going to always recreate the blog index. So we're going to check if the blog index is in the list of indexes. We have the list indexes method here. If it's not in the list, we're just going to create the index with the create index method. We call the index blog index and we have 1536 dimensions. You don't have to specify cosine similarity because that's the default. If the index already exists, we're going to delete it and then create the index again. So we always will create or start from a fresh index with this script. You don't have to do it that way. This is just how it's done in this one over here. After we have created the index, we set the index using Pinecone index and we store it in the index variable. Now it's time to parse my RSS feed. So we're using feed parser for this and we just need the URL to our RSS feed for my blog, that is this URL. We use feed parser to parse that URL and we store the feed, which is a collection of entries in the feed variable. We print out the number of entries first and then we are going to enumerate overall the feed entries, but only the first 50 entries. I'm gonna have a number from 0 to 49 and then each blog post entry will be in there. Now note that the feed does not contain the full article, so we have to get that article using the requests library. So here we retrieve the full article, the full blog post from the entry.link. We then use Beautiful Soup to get that HTML, because it is HTML, and parse it into text. I don't want to see HTML code in there. And then I'm going to refine what Beautiful Soup returns even further by only giving me the contents of a div called entry content. This is now our article. Our blog post is stored in that variable. We should now create an embedding for that, which results in a vector. We are using the OpenAI embedding APIs with the input the article, and we're using the pre-trained text embedding ADA002 model. The output of this call is a longer JSON document, and within that JSON document we can find the embedding or the vector in the embedding property here. So we retrieve the vector using this piece of code here. Now what we're going to do is we're building in this kind of loop, we're building a list of Pinecone vectors and we are appending the vector we just created, this one over here, we're appending it to that list. Now Pinecone expects that we have a list of, let's say, tuples, and we have a tuple with 3 entries here. The first one is going to be like the key, which is in my case 0, 1, 2, 3 and so on, and then the vector unmodified that was returned from the embedding call. Now we're not going to store the entire article as text in the vector database, that would be a bit pointless, but we do need a link to the article. So when you store a vector in something like Pinecone, you can add some metadata as well. In our case, we have a metadata property called URL, and we're gonna have the link to the blog post stored in that metadata property. Once we have all the Pinecone vectors and our loop is complete, so our for loop is complete, we can basically use upsert on the index to upsert all of these vectors at once. And yes, it's an upsert, so I don't really have to delete my index all the time. If I just want to have my last 50 blog posts, I can just rerun this on an existing index and it will replace the vectors when they have changed. For example, when I added a blog post to my blog. So that's it. That's the script. Just 65 lines to store all of our blog posts as vectors in Pinecone. Now let's turn our attention to the web app. So the UI you have seen before, you can find that in the web app folder in app.py. I'm not going to discuss Flask or all the details about this. I'm just going to check a couple of things. First of all, the method that's called in Flask when I click the submit button is going to be this one, right? The query method for the route/query. What I'm going to do is just retrieve the query and do some basic checks that you basically enter a query or not. I'm going to also check the model from that drop down that you have seen. I'm going to verify if it's in a list of allowed models. If it is, we continue. Now, if the model is GPT-4, as I've explained a little bit earlier, GPT-4 supports much more text that you can submit to it, and that results in it supports just much more tokens, because the model doesn't work with your text as is. It converts your text to tokens, and then there's a limit on the amount of tokens that you can send and receive back. When the model is GPT-4, I'm gonna say, well, you know what, when you reply to my question, you can use 1024 tokens. With GPT 3.5 Turbo, only use the default max tokens of 250. Now, of course, we typed in a query. We need to vectorize this query, right? We need to create a vector from the query text that we have entered, and we do that just as we created vectors from our blog posts. It's the same code. We're going to use the text embedding ADA002 pre-trained model to get the embedding. That results in a vector that we can then use to do a vectorized query with. Now, I don't have to know anything about how that really works, because I'm just using the query method in Pinecone to ask Pinecone, hey, you have to do a query against a vector stored in your database. Find the 5 most similar vectors to the query vector that we just created with the OpenAI embedding call. And also include the metadata, which will include the URL that we stored together with our vectors. When we have the different responses that are in search response matches, that's basically a list that you get there, we're going to call a function called getHighestScoreURL. Now you can find that function in the code. It'll just find the highest scoring document and return that, but only return that if the score is above 70%. Otherwise, I don't want to do that. Basically, that means that if the score is not high enough, the URL will be empty, and I will actually tell the user, I only found some low scoring results. Please try a different query. I didn't find a really good match for what you are asking here. That doesn't mean there isn't a good match. It could actually be that this lower scoring match is the thing that we need, but we just built that in also as an example to see how you can manipulate a bit what happens in that in the UI. Now, when I have the highest scoring URL anyway, what I'm then going to do is, of course, again, retrieve the blog post from that URL, because I need this as context, as context for my call to the ChatCompletion API. And I'm not going to grab the entire HTML, just like before. I'm only going to get or grab a specific div with a class property of entry context or content. Now we are ready to basically, at the end, ask OpenAI the real question with the article as context. So I'm going to do a call using the ChatCompletion API, right? And we're going to use the model that we set, which will be by default the GPT 3.5 Turbo model. And of course, this is the chat completion. So we have let's say, an exchange of messages. So we start with a system message, and then the user asks a question, the assistant responds, and so on. Now, we're not really doing a chat here. We're basically just asking one question, but we're using the chat completion APIs because, yeah, that's 1/10 of the cost of doing a call to the completion API with, for example, the DaVinci 003 model. Now, of course, the prompt is important here. So at the system level, we are just saying you're an assistant, you only provide relevant answers. And then I'm basically building a prompt here that says, answer me only if the article below the 3 dashes is relevant to the question. And then, if relevant, answer in detail and with bullet points. Here is my question. And that's the actual query that you entered in the query box. And then we add the content as well, the actual article, after the 3 dots here. So we have quite a large prompt because the article can be quite lengthy, can be quite a lot of tokens. And it's quite possible that the article is too long. If the article is too long, of course, we'll get an exception here. In that case, this one will be triggered error with the OpenAI completion. It could be that the blog post is just way too big. There are ways around it. For example, I could make some chunks of my articles and vectorize all those chunks and so on. There are ways around all of this, but we didn't choose to do that here. And please also note that we set the max tokens for the reply. We set this to the max tokens variable we set earlier. So if we use GPT-4, then we have a higher reply quota, so to speak, to choose from. Now, the actual call is going to respond or going to result in a response here. So response choice is 0 message content. That's going to be the actual response from the model. And I'm going to put that into response text. Now, response text is then just going to be returned to our HTML page. So we return a JSON object with both the URL and the score and the response text. And that is then just visualized in the HTML. And with this, we have come to the end of this video. I hope you liked this video. Be sure to check GitHub for the full code. And if you have questions, do not hesitate to open up a GitHub issue or use a comment here on this video. I hope to see you soon for another video. Bye bye and take care.